Hello and welcome to SynthFest. I'm Hugh Rob Johns, I'm the technical editor for Sound on Sound magazine, and I'm your introductory host for you today. But let me get straight onto it. Tony Wride, Exclusively Analogue, is talking about E-Mu, 50 years of E-Mu.
Sort of. So, first of all, do you feel the love? It's splashing away there, so it works. That's just using a couple of tracks. I just thought I'd play that just as a bit of an introduction. 50 years of E-Mu Modular. First of all, introduce myself, Tony Wride, Exclusively Analogue, and joining me on the stage here is Rob
Keeble from AMS Synths.
Okay, and we're covering 50 years of E-Mu Modular. So the first question I've got, if I can see anybody here born before 1955? Oh, there's actually somebody older than me. That's pretty good. Okay, so just a quick introduction to who we are. Well, first of all, I'll introduce me. That's me in a previous life, way back in the 80s. That's me up until February 2020, when I escaped from the airlines just before COVID. And my music career, just going through it, some of the highlights that happened. I started my journey on the 8th of October, 1955. Work that one out. 1977, on board HMS Hermes, I built my first synthesizer, which was the Minisonic, and you'll hear Rob did much the same, but somewhat earlier. Built a couple of transcendent synthesizers. The Yamaha DX7, or DX Owners Club, was a little bit of my baby. Okay, digital, not analog, but it's one of those things I sort of got into programming it, got people together, and we ended up putting out more and more sounds and trying to explain to people how to get the best out of this instrument. Yamaha ended up taking it over because I ended up having to go off and put one of those oxygen masks off and fly a different aircraft, so I ran out of time. 1982, still working for the airlines. I put here the bargain. I'll talk about that later, but did some work with Erasure and Keith Emerson. 1990, I was just doing restoration of synths, more as a hobby. It wasn't really a business. It was just I'd find them, repair them, get them fully working, and then various people, studios, musicians would end up having them. Or they come to me and ask me to repair them. The Aviator was possibly appropriately named, if you look back at the previous history, was my idea of combining all the best things I'd seen in the various synths and trying to get them in one box. So if you look at it, it's a semi-modular, because there's lots of patch bays. You'll see it a little bit later on, and it's on the stand. Captain Techno. 808 State ended up getting a Oberheim 4-voice from me, plus a couple of other bits and pieces. And Graham Massey of 808 State, it's in an article, I think it's in Sound on Sound, came up and said, oh, we've got this great guy, he's very good at repairing all these old synthesizers and finding them, and they nicknamed me Captain Techno. So that's my small claim to fame. And then 2011, really what we're going to be looking at here is what I call the Pioneer Tribute System. Okay, it's a tribute, and it's my tribute to the guys way back that started in 1972, started the E-Mu company, and built the E-Mu Modular. And tied in with that, 2015, working the airline, happened to fly across to San Francisco with 3 days there, went and met Dave Rossum, who is the man behind all of this, and you'll hear more about that a little bit later. So, Keith Emerson, a younger me, working on the modular. This is one of the first things I custom built, which was based on the ARP sequencer, but it has a quantizer built in to it for scales, and tied in with a little bit of the later story, I ended up meeting Clarke and built that for him, which is a 6-channel ARP sequencer. So that's it, a rough picture. That's actually in the Human League studio with an Aviator, and that's in Vince's, best to describe it as a huge igloo, which was his studio down in London. That's the Aviator, the later versions, 2 of them, different colours, but hopefully you can see the idea of that is it's got a lot of jack sockets on the bottom. It works from go, but you've got a lot of options in terms of modulating. There are 43 of those out in the music industry, still going strong, but the thing that's happened now is, of course, as I'm sure you all know, lots and lots of equipment is coming out, particularly in the Eurorack, at very, very reasonable prices, and there are companies that are producing copies of, for instance, the Moogs and Buchlas and all sorts at very, very reasonable prices. This becomes, unless somebody particularly wants one, This is very labour intensive, so price-wise, it's never going to compete. This is the very last one I built for a studio in Germany using the smaller knobs on it. And this is the Pioneer project. Okay, so this is my take on the E-Mu Modular. And a lot of this is a lot of thanks to Rob, because Rob's a technical man who had all the details for me to be able to do the work to produce this. That's me with Dave Rossum, first meeting, and then I ended up in 2016 helping him on stand for the Rossum Electro-Music modules, which you'll see a little bit of later. If you haven't had a look at them, they are tremendous. Dave is an incredibly clever person, and he's progressed on now to produce some really, really good modules. So if in your system, if you're looking for something that's really, really powerful, I strongly recommend having a look at the Rossum Electro-Music modules. So, over to Rob.
Thank you, Tony. Hi, everybody. So last time you probably saw me was on a Behringer video shot in Woolwich a few years ago. But just to give you an idea of what I've been up to, so I think everybody in the UK in the late 70s, early 70s built a Minisonic. I was one of them. And that really started my love affair for synthesizers. I then went on to study that electronic engineering at University of Essex. And I set up what was called the Emulator Archive in 1998, and that kind of documented everything about samplers, the E-Mu samplers, but it led me to interview Dave Rossum in 2001, and Scott Wedge as well, and Ed Rednick, and the main senior team, Dan Amassi as well. And one of the things I did was retrieve as much as I could in terms of schematics. A lot of it had been binned, but retrieved as much as we could on the modular stuff. Also, it was the 30-year history in 2001 on sound. You can check some of the back issues, and I wrote a 3-part article at that point about the whole of E-Mu systems. So I built a clone in 2003 before Tony started doing some work on it as well, using original parts. And then I founded AMS Synths in 2012, very small boutique manufacturer of analog synth manufacturer. So we do Eurorack modules, and I've built about 1,500 of those. Also worked for Behringer for a couple of years, acting as electronic engineer, consulting on 3 projects, one which hasn't yet appeared, the 2500 replica and the 2600 replica as well. But also did some spot consultancy on things like the MS-101 and also on the Moog Modular to try and make sure it stayed in tune. So I'm continuing to run that as a business, and you're welcome to stop by the stand and pick up a business card.
The other person that's going to be taking part this afternoon, in a roundabout sort of way, is Dave Rossum. Basically what I did was give him a list of questions that I thought you might ask, my best guess, and then he's provided the responses. So you should find that. So that's a very young Dave with a E-Mu Modular system, one of the early ones. That's a slightly older Dave, and that's a definitely older Dave with E-Mu Modulars in the background. So those that you've seen there are all originals. This is another original system. This belongs to a producer, musician, who ended up, he had an initial system, then he bought another system, which I'll come back to. Take a look at the keyboard, if you can see the shape and style of that keyboard, because that'll pitch up again in a minute. But basically, he expanded up that system, and there's also a few of my modules have gone in there to make this much bigger system for him. It's one of his favourites. A lot of musicians that have got the E-Mu Modulars really, really rate them. There's another system, same thing. This is Chicago University. Their system they've had right from the beginning, in constant use, and I've ended up helping them in terms of providing repair modules, things that have gone wrong. Currently, they're after a couple more oscillators to fix that system. So one of the things I'm trying to do is also, apart from doing things I want for myself, is provide a service to people that have got E-Mu Modulars to try and keep them going. Anybody know the Chemical Brothers? Tom Rowland's system, which I went down and had a quick run over, and there's a couple of bits that have been fitted to that as well. And then this one. Any difference between what you've seen so far? No? This is one of my systems, built for a friend of mine, who's part of Eat Static. This is an even bigger system for another member of Eat Static, and he's got the combination of the Eurorack at the bottom, the Pioneer stuff in the middle, and then space at the top, which he's now filled. He's got a huge system of modular. Picture of one of the modules. This is a standard module, voltage-controlled amplifier. So if you look at it, it's that silvered face, the aluminium knobs, all the bits and pieces with the blue edging. That's another one, the high-pass filter. This is the back of a module. Okay, this circuit board that you see here, the main circuit board, is an original 1973. And if you look at it, on top of that, they have the sub-modules. So what E-Mu produced was either the complete module, or you could buy the sub-module and then build up your own circuit board and build up your own system. On their oscillators, one of the great things about these is they were very, very stable. Dave will make mention of that in his videos a little bit later on. This is the back, and again, this time you have two sub-modules. The bit on the right is the main oscillator core, and then there's a wave converter, a wave converter on the left-hand side. Two modules, one marked US, because it definitely doesn't work with 1200, and on the right-hand side there, that's one of the ones I built up. So that's what I'm going to be replacing those modules in the Chicago University system. Universal active filter, you'll hear mention of this later on. A lot of people class the universal active filter as one of the best filters ever. Dave will talk a little bit about some of the history behind that, but most people that have used this really, really rate it. There's the two circuit boards, the original on the left, mine on the right. It's all the same components. Fortunately, thanks to all the input from Rob, able to source all the components to make an exact. It's not exact, because if you look, one's very curvy, one's very angular. Okay, does anybody spot one big difference between this modular and most modulars? Open question. What's missing? Correct. This system was designed so that it could be set up as a run straight away with no patch cables. You have pre-patching, and I don't know whether you can see them on this picture. It's not that clear, actually, but there are wires at the back. There are patch points you can pre-patch. So you can take, for instance, I'll take the sawtooth waveform out of one of the sawtooth pulse and feed that into the first input to the VCF, or run from the mix, and then you can take it from the low-pass filter down to the VCA, and you can take from the envelope generator feed straight up to the VCF and also to the VCA. The way it works is if you plug into an input, for instance, that has this pre-patch, you override the pre-patch. So it doesn't mean it's pre-patched to a point, but you can override and do what you want with the system. So you can see them a little bit better on these. So that's one of the advantages. So that's just a little bit of background, as it were. I'm going to hand over to Rob, who knows far more on the technology aspects of this. So, over to you, Rob.
I won't dwell too long on the technology so we don't all fall asleep, but I thought it'd be useful just to touch upon the technologies that were used by Dave and the team over the 10-year period of 1972 to probably when the last modular was built around 1981-82. So in those days, that picture there is how you made PCBs. Today I use a modern computer and it can route things in a matter of milliseconds. Of course, in those days you had to lay it out using mylar film and tape. So that was quite a laborious process. It also meant if you got it wrong, you got really frustrated because you had to start again, cutting it up and building some more tape. So there are kind of three waves of technology that are relevant to the modular. The transistor years in the early days, then the arrival of CMOS technology, which of course fueled a few other things as well, and then the Z80, the original really useful 8-bit processor. It wasn't the first. Intel did a 8080, and the Z80 from Zilog was a better system because it had a development system with it. And then Dave went on to do some custom chips. So we just want to just give you an idea of what the tech behind it is. It looks really old-fashioned at the beginning, and it was. It was using a lot of technology from the late 1960s, particularly from the space program, which Dave was quite interested in. He was quite into space rockets at that point as well. So the original technology is quite old, and Dave did a tremendous job making sure he created stable oscillators out of this relatively old technology in 72, and was really ensuring that he had stable oscillators. We still use some of those designs today in terms of the exponential converter, but also the filters, very clear filters, very different to a Moog filter, which would be overdriven, be very clear, and you can probably hear that in the demos that Tony's got. Some original OTA chips, and this all gave birth to the original range, the 2000 range of modules, and really the initial keyboard. So the initial keyboard, the 4003, I think it's called, it uses TTL chips. Now, TTL chips are transistor logic and quite old, 1960s based technology. They consume a huge amount of power, and that's the main downside of trying to utilize this technology. To give you an idea, the ALP sequencer that's in the 2500 uses over half an amp of power just to get you through 10 steps, sequence steps. So TTL isn't a particularly great technology to use in synthesizers. And really what happened in 75 to 76 was the CMOS revolution. This is where you're starting using metal oxide semiconductors, and that transformed the way in which you use op-amps, because you could get nice buffers in there, which would make it more stable. It also led to the replacement of TTL. So that enabled Dave and Scott to put together things like the miniaturized keyboard, the monophonic one, which used CMOS logic, which was then utilized more broadly. It also got into the digital technology. We haven't got a digital sequencer here or the analog one, but that's what really gave birth to those ideas, was the use of CMOS technology. RAM at that point was really out of the reach of anybody, so you did see the arrival of various early RAM chips, 2101, but they were really expensive and really small, so you really were playing around with maybe a kilobit, so remarkably small spaces. What then happened as you got towards 1976, was something big happened. I was at University of Essex when this came out, and it was a tremendous revolution to have an 8-bit processor, but one that had a development system around it. So everybody latched onto this, and of course the positioning of Dave Rossum and Scott in Silicon Valley at Santa Cruz meant they could get a hold of this technology very quickly. Literally they would go around the factory and buy one out the back door. So they were able to get onto this microprocessor revolution very quickly, far more quickly than we did in the UK. It was probably another couple of years. And even Roland didn't get into these types of processors until they got into the Jupiter 8 a few years later. So Z80 is very important. It's got a lot of chips around it that help it. It also, while Scott was programming this, so he did the polyphonic keyboard, which does 16 voices, which is the first time that had been done. Dave was actually starting to work with Ron Dow at SSM, and SSM were starting to develop their own chips. So Dave designed a whole series of components from VCFs to VCAs, and they figure in the later modules. So as you saw earlier, there were submodules on the back. It enabled Dave to upgrade him. So if the design wasn't quite good enough, he could put a new submodule in and upgrade all the ones out in the field if he needed to, or just simply upgrade the design as it went forward. A lot of this stuff got used in the Audity. If you ever want to research a really expensive synthesizer, they were £200,000 in today's money each. They were 16, 32, or even 64 voice. I do have the schematics, we saved the schematics from it, but the software for the controller was never written because essentially they realized they wouldn't sell very many. So that went on to the emulator, and that's a whole different story of digital technology. But even in the things like the Emacs and Emulator 2, or even in the drum machines, you've got SSM chips, you've got that analog warmth, which Dave designed. So hopefully that gives you a bit of an idea. Lots of revolutions happening very quickly, which really enabled E-Mu systems to grow. Plenty more in the 80s and 90s, of course, as well, but that's something separate. So on the left-hand side, you can see what the technology was in 1972. Very much the blue PCBs laid out on tape. And on the right-hand side, you can see Dave was actually not only got a polyphonic keyboard, but he had a disk drive, albeit 8-inch, and he had a CRT, and it never actually worked with that system. But that's where they were just about at towards the end of the 1980s, really coming up with an analog Fairlight. The keyboard acted as a sequencer, a bit like a System R and a Fairlight. So tremendous leaps over that 10-year period.
Okay, so to move on, $250 bargain. What would you think would be a nice $250 bargain? How about an E-Mu modular system complete with keyboard? That cost me $250. Okay? Story goes, I had contacts in the States, and they told me in Madison, Wisconsin, in a pawn shop, they've had a modular system for the past 8 years. They just want to get rid of it. So I phoned them up and said, I've been told you've got this. Yeah, what is it? Can you tell me about it? Oh, we don't know. It looks like something home built. Nobody can get it to work. Nobody can get it to do anything. And I said, well, can you send me some pictures? No, not really. Are you interested in it? Yeah, depends on what it is. Can you tell me more about it? Well, it's got these sort of aluminium panels and lots of knobs and lots and sods in there. And I said, well, yeah, I'd be interested if only I knew what it was. I said, without knowing what it is, if you can't send me pictures, I'm sort of buying it blind. Well, make us an offer. $250? Okay, yeah. Arranged it because I had to ship it over to Bangor in Maine. So this was shipped across, because the airline, remember I worked in the airline, we used to fly into Bangor, Maine. A week and a half later, I arrived at the hotel and they said, Tony, we've got 2 big boxes for you. And I said, what do you mean 2 big boxes? There are these 2 flight cases for you. Brought up to my room were 2 full aluminium Rode cases. The cases alone were $250. So there's a big case containing the module, put that off and went, wow. Opened the keyboard case and went, wow, because that was the keyboard. So, have you been paying attention? Have you seen that keyboard before? Where? Earlier, yes, with one of the systems. So Ben Edwards' system, the one I showed you, the big system with the cabinet on top, that keyboard's with him now. Have you seen this case anywhere? Just here. So, basically having got this system, I looked at it and just went, wow. Apparently not working until you tap the submodule at the back and all of a sudden the oscillators work and the whole thing basically fully worked apart from 2 broken keys. Fully working. So shipped it back, paid all the customs duty, etc., got it in, fixed the keyboard, got it all running, told a few people, oh, I've got an E-Mu Modular system, it's amazing. It's fantastic, it looks great, love it. Phone call. Hi, Tony, this is one of the shops in London. I understand you've got an E-Mu Modular system. Yeah? How do you know? Oh, we were told by somebody mentioned it. Oh, we're interested in buying it. Didn't know I was selling it. We are really, really interested in buying this. We have a customer who's been searching for an E-Mu Modular for several months. Can you send us some pictures? Boop. And go the pictures. The next minute say, right, we're definitely interested to buy it. We're making you an offer considerably more than you paid for it. I mean, considerably more than I paid for it. But we need you to bring it down to demonstrate it to the customer. So, dutifully off down to London. Walked in, there was Vince Clarke of Eurasia. So I ended up having a chat, showed it to Vince, and he said, actually, Tony, really interested, but I've actually found a bigger system, which I'm actually going to buy. However, the shop, true to their word, bought it, put it on display, lots of people interested. This eventually went to a museum, and then it eventually ended up, several years later, being sold, bought by Ben, who took the modules out of that, ended up with an empty cabinet and the keyboard. And I've ended up with this cabinet because it was sitting doing nothing, so I thought, great, I'll use it. So that's a full circle. From Vince, that meeting led on to, remember I showed you what I call the Vince sequencer? Because Vince said to me, do you know this stuff? I said, sort of, I'm not an engineer, but I enjoy it. And he asked me to build that 6-channel sequencer. So that's tied with Vince and some of his things. These systems, if you know, the original systems now are definitely into the 20, 30, 40,000 pound bracket, because there aren't that many of them. So, the modules. Just a quick look. I, having sold that system, went, oh, that's a shame. I really like that. And subsequently, I got in touch with E-Mu, who's still running. Bear in mind, this is 1992. And ended up speaking to Dave and said, Dave, yeah, this, I've just had this, blah, blah, blah. And have you got any bits left over? And Dave said, oh, yeah, we've got a box full of spares. I said, do you want to sell them? No, you can have them. So he shipped me a box full of unused circuit boards, basically, and various other bits and pieces. I went, great, I can do something with this. And also, not long after, I bought another system. But it was on pieces of aluminium with somebody's own circuit boards, but it had the submodules. So I said, at some point in my life, I'm going to spend the time and I'm going to build up a proper system. So what you see in front of you, the ones on the left, that's my version of the standard sawtooth pulse in here. And then the newer ones, which I've just recently done, the multi-waveform VCO, is my progression on. So from the original E-Mu, parts very, very difficult to get, onto something that you can do reasonably at a reasonable price. So that's using the Curtis 3340 oscillator chip. Nice and stable, works very well. Voice controlled oscillator, that's the new one. Some added features. This is the low pass filter. I have kept the core of the low pass filter exactly the same as the original, but added in the resonance control. And you have the option, as was mentioned here, because of its submodules, if, for instance, you wanted an SSM 2040 or the new SSI 2140 filter chip, that can go in instead. It gives you the flexibility, certainly for the low-pass filter. And I'm working on a sort of updated universal active filter at some point. But the idea is to be able to produce something that has the look and the quality of the E-Mu Modular, but at a price that's not into 10, 20,000 pounds worth. So, dual transient generator, another one I've just done. This is again using Curtis chips. So it does all the functionality, and then the dual voltage controlled amplifier. That's quite useful. If any of you have used voltage controlled amplifiers, certainly a pair of them, you can do lots of really nice effect, either panning, but what's also quite good, something I do quite often, is you put high pass in the top, low pass at the bottom, and have it shifting as the sequence is playing between the two filter modes. Quite a nice effect. So now we come on to question and answers.
This was our original logo. You can see it on this very well-loved T-shirt that I'm wearing. E with the Greek letter mu, and that was the company name, logo, and the way we spelled it from when we started the company back in the early days until we actually had to incorporate in the state of California. And the state of California said we can't use Greek letters in the name. You have to spell it mu. It came about at the very beginning of my synthesis career. I discovered the Moog synthesizer at UCSC and got excited about it. Got together with friends from my alma mater at Caltech. And over the last week of 1970, between Christmas and New Year, I'd gone down to Caltech and got together with my friends Jim Ketchum and Steve Gabriel. We decided we wanted to build a synthesizer. And in the basement of Dabney House, we started prototyping some circuits. And every time we'd phone up the electronics companies and try and order some parts, they'd ask us, what's our company name? And after a few times of being embarrassed, we decided, let's brainstorm and come up with the company name. And I suggested, how about E-Mu, short for Electronic Music Systems, with the kind of clever pun in it that the mu is a Greek letter, mu, which is also the symbol for micro, because we were ordering these little tiny integrated circuits, brand new, highest tech stuff at the time. So that suggested the miniaturization in microelectronics that was part of the company founding. We started that project down at Caltech, and during the spring of Caltech, we built our first synthesizer. It was called the Black Mariah. It had a matrix switch in it. It had really primitive circuitry in it. It was pretty horrible. So we pushed it out the library window after we played with it for a couple of days and decided to start over. We did take the matrix switch out because it was really expensive. Over the summer of 1971, here in Santa Cruz, we designed our next synthesizer. We called it the E-Mu 25, and it was more akin to the ARP 2600. It had a fixed front panel. There were modules in it, but there was no changing of the module complement. And that was a competent synthesizer. At the end of that summer, I was joined by my high school friend, Scott Wedge. And Scott and my girlfriend at the time, Paula Butler, and I decided we were going to continue the E-Mu Systems project up here. As far as the intellectual property we developed, we decided the Caltech group and our group both had equal rights to that. We'd get the name E-Mu Systems, and they'd get that E-Mu 25 Mark I, which they took back with them at Caltech, and they continued their studies and have had some rather nice careers in audio and things like that. We took E-Mu forward, built a E-Mu 25 Mark II, and at the end of that, we looked at what we'd done and realized we were absolutely as good at circuit design, probably better than either ARP or Moog or Buchla, any of them. So we decided we can play with the big boys. Let's do it right and build a modular system. The other thing was, I just loved the Moog modular, and so that was really the direction I wanted to go. Well, as I said, our circuitry, I already felt was as good. Really, I felt it was better than what Moog and ARP had already done. The Moogs of the time were notoriously unstable. They were sometimes called voltage-controlled thermometers. And our oscillator, the E-Mu 1200 submodule, ultimately replaced by the 1201 submodule, were incredibly stable and incredibly accurate. They were more exponential than ARPS oscillators. We had filters and amplifiers. All of these things just had the greatest circuitry. And so I felt we actually could beat them on circuit quality alone. But the other thing was that when I'd gone back to UCSC and seen after a year and a half of use, that poor Moog Model 12 with its broken plastic knobs and dented front panels and broken connectors, I realized how hard students were on a modular system. And that was where modular systems were going, largely, was into universities. So I decided that if I built a modular system, it was going to be bulletproof, that you could take a hammer to it, aluminum knobs, 1/8-inch thick front panels. And so that was how the E-Mu Modular was designed. We succeeded, I think. I know of one synthesizer. It was sold to the Art Institute of Chicago, the School of the Art Institute of Chicago, in 1975, and has been in continuous service even to today. Then the final thing, and I think we tried to build on what Don Buchla had done, was really embracing the modular concept. We designed the E-Mu system, unlike the others, so that all the different kinds of signals use the same jacks and the same voltage levels, so that you could take an audio signal from a filter and use that to trigger an envelope generator as a gate, or as a control. You could put your control voltages through your filters and process them before going back into the pitch of an oscillator, things like that. A signal is a signal is a signal, and all the modules would talk to each other. And then we got wild ideas for different modules. And this really, like I say, was inspired by Don's embracing of the modular concept. And probably Don has maybe planted the scene in my mind, which ultimately became the modular sequencer, where you patch together logic modules to create a sequencer of your own design. And so all of that came together. 1973, we produced our technical catalog. And this was a description of everything we made. And it was loose leaf, so you could keep adding things because we did. After we'd come up with the sort of industrial design that would be so solid, we ended up with these 3, 6, 9, 12 wide panels, very spacious. I always liked the spacious design, and we tried to keep the signal flow very obvious. That dictated these large square panels. We needed something to separate the modules, hence a border. And I always loved the look of brushed aluminum. Back in the 70s, it really looked high-tech to me. So the brushed aluminum and my favorite color, blue, were pretty much my decision. I guess I pulled rank and decided on that. Well, the 2100, it was one of the very early designs. I always loved the sound of that Moog ladder filter from the very moment I first heard it back in that music room at UC Santa Cruz. But my passion was to have, I love designs that are just purely one simple essence. And so I wanted to get rid of the AC coupling and input level shifting that Moog put into his ladder. And I wanted to somehow get the signal out of the ladder without any more coloration to it. So I have to pull up a schematic now and then. It's just who I am. So here we have, this is that essence schematic. There's the Moog ladder. You can see the rungs of the ladder as the capacitor. And you can see that I bring the signal in right at the bottom of the ladder, just straight into it. That's how it works. The hard part was getting the signal back out. That at the top of the ladder, the signal is just a little tiny thing, and you need a high gain amplifier. And for the first several months I was designing that filter, Everything I tried was either too noisy or had too much distortion, or sometimes both. And then I think this is probably the first circuit invention I ever did. Very early on in my career, I realized that if I turn the input stage upside down at the top and put feedback around it, I could yank the signal out in exact inverse, putting the signal in, and that meant that the entire filter was non-distorting, and that last stage used its own gain, so I got no more noise or no more distortion than was natural in the filter itself. And when I listened to it, it was exactly what I sounded. So I think the answer to the question, yes, this was very much by design and a lot of hard work and creativity. Oh, that's a wonderful story. The universal active filter fairly obviously was born from the ARP 2500. Back in that basement of Dabney House at Caltech in 1970, we had the ARP 2500 catalog. That was where I discovered what's technically called the state variable filter. ARP called it the multi-mode resonator. And it wasn't but a few months later that we found a design for that in the Burr-Brown op-amp handbook, using Burr-Brown multipliers and their op-amps. But we substituted the op-amps, the integrated op-amps we were using, which are much less expensive than Burr-Brown's, and changed the multipliers, again an expensive component, into CA3080s. And that made a very functional state variable filter, which ultimately became the E-Mu Modular's resonant filter. But ARP's spec in their 2500 catalog was that they could span a cutoff frequency range from 20 hertz to 20 kHz and a resonance or Q from 1/2 to 512. So that was my goal in the universal active filter. And those first circuits just don't even come close. And I worked and studied and finally realized that there was just an inherent limitation. I was using op-amps with a gain bandwidth of 1 megahertz. And if you multiply 20,000 times 500, you end up with 10 million, 10 megahertz. So there was no way with those inexpensive, stable, and simple op-amps that we use everywhere else to be able to build the functional filter that the geniuses at ARP, Al Perlman and Dennis Collin, I was sure had designed. So stepped up to the high bandwidth op-amp you could buy at the time. It was called an LM318, had a 15 megahertz gain bandwidth, but boy, was it hard to keep stable, and figured out how to keep it stable. And I still wasn't getting there. And so had to get rid of the 3080 ICs that were the standard VCA. And I invented my own VCA that had pretty much the ideal characteristic. So once again, I'll show you a circuit. Here we've got that 318 op-amp as the integrator in the filter. And this VCA, which requires 2 rather than 1 control currents into it. I've never seen this used in any other synthesizer circuit. I'm sure people have, it's too simple a circuit for it never appeared before, but it's probably just used in RF stuff. But that was the magic that created the UAF. And once I got there, I was getting these incredible resonances. You can take this UAF and crank the frequency way down to the sub-audio and kick it with a signal on the input on a Monday and come back a week later and the thing will still be ringing. The thing sounds incredible. It's a wonderful filter. And it wasn't until 2 years later I actually saw an ARP 2500 filter and discovered that, no, they'd use LM301 1 megahertz op-amps. Their filter didn't meet those specs at all, but they sure fooled me and ended up with a wonderful design. Well, I don't think I ever really said I would never have anything to do with analog. That's probably a misquote. But I very much suspect that I did say that E-Mu, probably back in the late 90s, would unlikely ever get back into making analog products or modular systems. Back at that time, I had friends that were buying used Moog modulars for a few $100s from universities that just wanted to get rid of them. So it didn't look very likely at the time. But of course, the pendulum swung, and in around the 2010s, Dieter Doepfer had popularized the Eurorack module, and I thought that was a wonderful thing. And Dave Smith, who was back making vintage synthesizers. So I saw an opportunity to get back to what has always been my true love, which is analog circuit design. And so we started up Rossum Electro-Music, our first module, and we sort of, we loved the metal knobs and the brushed aluminum look, so we stuck with that for Rossum Electro-Music. And our first module was an enhancement of the 2100 filter, where I took a ladder filter and invented some new stuff, because that's what I love to do, invent new analog circuits. And here we are. In that Moog room at UC Santa Cruz, we keep going back to that because that's where it all started. I was teaching the music students at Santa Cruz how to use the synthesizer. And the first question out of virtually every student's mouth is, why is it that I can only play one note on this keyboard? I want to play chords. Everybody back in the early 70s was talking about polyphonic synths, even though they didn't exist. ARP came up with the two-note keyboard that would play the lowest and the highest note. And as a result, just about everybody was thinking in terms of keyboards that would have a different synthesizer voice for the lowest key you pressed and the next lowest, and so on to the highest. But I realized that wasn't going to work. Instead, however you assigned the voices, the assignment algorithm had to be a temporal one: the first note, the second note, the third note. Now, my education at Caltech was in biology and computers. And so I'd taken the computer hardware course, and I knew how to design computer logic. So I worked out in those early days the logic equations for a proper assignment algorithm. And sometime in late 72, early 73, got a bunch of TTL and built a logic board that actually executed the polyphonic synthesizer logic algorithm. That sat on a little board in front of this very system. This is actually the very first modular system. Some of these are original prototype modules. This was given to me by Creative when I left Creative back in 2011. Anyway, this logic board, early 1973, as soon as we had three synthesizer voices on here on the synthesizer, we could play three notes on our polyphonic keyboard. We didn't productize that until Leon Russell bought the first modular system from us that was really big enough to support a polyphonic keyboard. That we sold him back in 1974, I think, and he first used it on an album in early 1975. About that same time, Tom Oberheim came to visit us. Tom and I became good friends. And Tom was interested in taking his synthesizer expander module that I actually helped with the design with and turning it into a polyphonic synthesizer. So Tom licensed our polyphonic keyboard and used it in the Oberheim 4-voice. Eventually, we took that hardware logic keyboard and instead turned it so that it used a Z80 microprocessor. We were also good friends with Dave Smith, and when he saw all of that and our SSM chips that we designed, he got inspired to do the Prophet 5, and Dave licensed the polyphonic keyboard and actually developed all of the Prophet 5 original software on our Z80 system that we'd used to develop the keyboard. So those were the very first aspects of that polyphonic keyboard. In reality, those logic rules that I came up with back in 1972 are what is used in virtually every polyphonic synthesizer, be it analog or digital, all the way today. The actual count, I don't think anybody really knows. Some of that is because what is a system? If somebody buys one cabinet and then buys another, did they buy two systems or one? It was about 200 cabinets that were sold. And again, I don't have an accurate count on that. The actual numbers were lost before you even stopped building modular systems. About 1,000 oscillator submodules were built. We have that from the serial numbers of the last few of those. So that gives you some idea. So I would say it's somewhere between 100 and 200 systems, you could say, were really built. And yes, Scott still has his modular system. I'm sure he's very proud of it. And I don't know if that actually was the last modular system built or not, but it was certainly one of the last, and we gave it to Scott as a gift. You know, my passion is designing circuitry, algorithms, things like that. I want to push the state of the art for musicians forward. And I've had a wonderful opportunity to do that with Rossum Electro and the Eurorack format. I have too many other things I want to do to be focusing on changing the format of the modules. And I guess in a way, besides Tony and his Exclusively Analogue stuff, has done a wonderful job of reproducing this format. So I'll leave that for other people. I'm back to analog design, which I truly love. Well, I think there's a number of reasons. The first is digital technology can arbitrarily duplicate any analog system with sufficient compute power and sufficiently good engineering. But the problem is, if you take shortcuts in the engineering, if you make a mistake, those errors create distortions that are unnatural. They don't sound pleasing. They, some people use them. You can create aliasing and so on deliberately, but it's not the sort of stuff that you just love. Conversely, in analog, because analog is an analog of the physical world that already exists, when I make a shortcut, when I try something crazy, more surprisingly often, those things turn out to be interesting, exciting, musically useful. And I think that's why analog synthesis will always be with us, is because the nature of those analog deviations are the sort of things that make new sounds and allow us to be more expressive. Another reason, making music is an art. It's an emotional process. It's about emotions. And analog design, that I'm not a musician, but my analog designs also are art and emotional. I find digital technology, ones and zeros, to be very cut and dry. I find it very difficult to have an emotional relationship with a tablet or a keyboard and a mouse and a screen. But when I instead am touching analog components and devices, now I can get emotionally involved. I think the same is true of musicians. They want to have this emotional relationship with their instrument, and that's much harder with a digital instrument than it is with an analog instrument. And I have to add a third thing. My alma mater, Caltech, there's a professor of neuroeconomics, Dr. Antonio Rangel, and he's done some very interesting experiments. He puts people inside functional MRI machines and gives them wine to drink. And he fools them. He makes them think they're drinking a wine that they think is much more expensive than it actually is. And looking at what happens inside their brain, it isn't that they're just fooling themselves that the wine is more expensive and therefore it tastes good. It actually lights up their taste centers more when they have or believe they have spent more money on the wine they're drinking. I talked to Professor Rangel about whether he could do the same experiments with audio and sound and music equipment. And he said, unfortunately, MRI machines are so noisy, that's not possible. But he said he had no doubt that the same results would come out of it. That if we believe in analog electronics and believe it sounds better, and we've spent our money on having a really fine vintage or even brand new analog synthesizer, the fact of that experience is going to make it actually sound better to us. It isn't we think it sounds better, it actually does sound better, be us the musician or the person listening to it who has the same experiences. So I say, that's great. Let's keep making analog stuff and let's keep loving those sounds as they light up our pleasure centers in our brain.
Just a reminder, Dave is still out there building a lot of really nice stuff. This is his Evolution filter. This is the Control Forge. This is absolutely stunning. Everybody's used to a standard ADSR, which is basically on here, Tacticate Sustain Release. This you can do go all over the place and do things that also do sequences. This is the Z-Plane filter. We mentioned that a bit earlier. That's there. That is an amazing sounding piece of kit. So that's got us to the end of this. We're running out of time, I've been advised. I hope you found it a little bit of interest, a little bit of history. You can look back and go, now you appreciate how important Dave Rossum, E-Mu, was in the sort of development of the synthesizer industry, and the E-Mu Modular in particular. So my part of all of this was to spend the time developing the modules. And basically what happened with Rob's help back in 2011, I had some time away from flying, from working part-time, and I sat down and designed all of the modules. So I didn't redesign them, it was basically designing all the artwork, all the circuit boards, et cetera, to produce the tribute system, and then progressed on that to the base of the Pioneer, which is, so the top half of this is all basically same circuitry as the original E-Mu Modular. The bottom half is all the new stuff with the Curtis chips. But the idea being that I would have a really nice system to replace the one I got rid of. And then fortunately, I managed to get the original cabinet back. So it's done a full circle. So from my $250 bargain to several £1,000s spent and hours and hours and hours to be able to reproduce this, primarily for my own use, but also some of the friends and studios and musicians have ended up getting some of this stuff. And also, it's enabled people that have broken systems get them up and running again, including Chicago University, which Dave mentioned. Thank you all very much. Hope you enjoyed it. Thank you, Rob.